Who's actually getting value out of a nozzle connector for a version 2.0 F200 laser head? And who would be better off looking elsewhere? If you're wondering whether this ZNNRKMYO part is worth the price for a regular day-to-day cutting shop, you're not alone. Link is in the description if you want to check the product details on Amazon. In the next few minutes, I'll walk through the kind of workflow this part fits into, the hidden trade-offs you might not see on the packaging, and finally a quick verdict on who should click Add to Cart and who should keep scrolling. Let's start with the problem most machine owners face. After a few weeks of cutting stainless steel or aluminum, the nozzle tip starts to drift, the fiber alignment gets off, and you either see a fuzzy edge on your parts or you have to pause production to recalibrate. That downtime is the real cost, and the component that sits between the fiber and the cutting head is often the culprit. The ZNNRKMYO connector claims excellent performance and high accuracy, which sounds great on paper, but the question is how that translates when you're actually feeding a 5mm thick sheet into a production line. From what I've gathered about the typical version 2.0 F200 setup, the connector is a single-piece alloy that screws directly into the laser head housing. The design is meant to keep the fiber core perfectly centered, which is essential for maintaining the tight focal spot that gives you clean cuts. In a shop that runs 8-hour shifts, the connector's durability becomes a measurable factor. Users have reported that generic, cheaper connectors tend to loosen after a handful of remounts, forcing you to retighten or replace them mid-run. The ZNNRKMYO part, by contrast, uses a reinforced thread that resists stripping, so you're less likely to have that creeping slippage that throws off your beam. Now, think about the type of material you're cutting. If your daily work is mostly mild steel for automotive brackets, the tolerances you need are forgiving and you might get away with a budget connector. But if you're regularly cutting thin titanium sheets for aerospace components, even a fraction of a millimeter off the focal point can result in a rough edge or, worse, a burr that requires secondary machining. That's where the high accuracy claim matters. In practice, the connector's internal alignment sleeve is machined to a tighter tolerance than many off-brand alternatives, meaning the fiber stays coaxial with the nozzle longer. For a shop that can't afford to scrap a batch because of a miscut, that stability adds up quickly. Installation is another practical angle. Some aftermarket connectors require a special torque wrench or a series of calibration steps that add minutes or even hours to your changeover time. The ZNNRKMYO piece is advertised as a plug-and-play unit. In real-world feedback from forums, installers note that you simply unscrew the old piece, slide the new one in, and give it a hand-tight turn. No additional gaskets, no alignment tools, no firmware updates. If your shop runs a changeover schedule where you swap heads multiple times a day, that simplicity saves you a tangible amount of labor. On the flip side, there are a couple of practical weaknesses you need to weigh. First, the connector is strictly for the version 2.0 F200 head. It won't mate with older V1.X models or with the newer version 3.0 series that some manufacturers are rolling out. If you have a mixed fleet of machines, you'll need to stock separate parts, which can complicate inventory. Second, because the connector is built for durability, it carries a price tag that sits above the lowest-cost generic alternatives. For a hobbyist or a very low-volume shop that only runs a few cuts a week, the incremental cost might not be justified when the risk of a misalignment is already low. In those cases, a cheaper part could be good enough, especially if you're comfortable doing the occasional realignment yourself. Let's talk about the value beyond the headline specs. In a production environment, the cost of a single scrap part can be anywhere from $50 to several $100s, depending on material and complexity. If a misaligned nozzle leads to a 2% scrap rate on a $10,000 monthly output, you're looking at $200 in lost material each month. The ZNNRKMYO connector's stable performance claim isn't just marketing fluff. It's a promise that the beam will stay on target longer, which directly protects that bottom line. For a shop that runs 20-hour weeks on a single laser, the extra $30 or $40 you spend up front can be recouped in just a handful of successful cuts. On the other hand, if you're a small-scale prototype shop that primarily cuts acrylic or wood, the tolerance window is much wider. A slight shift in focus won't ruin a part, and the time saved by buying the cheapest connector might outweigh the minuscule risk of a botched cut. In that scenario, the good durability is nice, but not mission-critical. You might also consider that the connector doesn't have any adjustable focus feature. Some higher-end connectors let you fine-tune the distance between the fiber tip and the nozzle, which